Earlier this month, the IoT Security Foundation announced its latest chapter in Amsterdam. So I'd like to give a shout out to the founders, Antoinette Hodes, Antris Shar, Asim Jakar, and Jan Jaeger. You can read all about IoTSF Amsterdam by going to iotsecurityfoundation.org/news. Or if you're watching this live, I'll put the link in the Zoom chat facility so you can click on that and read all about it. By the way, if you'd like to start an IoTSF chapter in your part of the world, get in touch with me and I can take you through the process. It's all very easy, and you can add your city to the growing list alongside Bucharest, Houston, Texas, Bangalore, Chennai, and now Amsterdam too. Onwards, and we'll now join Dr. David Long of Doulos. He is in Poole on the very south coast of England in Dorset. David's presentation will highlight how an SDL and the IoTSF Security Assurance Framework can be used together at each step to meet security requirements. If you'd like to hear from Doulos, a special web landing page has been created. Go to doulos.com/IoTSF webinar, or if you're watching this live, I've put the link in the Zoom chat facility. You know the drill by now. David's presentation today is entitled Securing Your Embedded System, Where to Get Started. Dave, the floor is now yours.
Okay, so hopefully you can all see my screen.
We can see that, Dave.
Okay, brilliant. Okay, so Doulos is a training company, and that means that we meet a lot of embedded developers. And a story that we commonly hear from them is that they're aware that security is becoming an issue. They don't necessarily have any expertise or knowledge about security, and they're a little bit sort of struggling when it comes to how do they get started. So that was the inspiration behind the sort of quick chat I'm going to give you today. Okay, so let's just give a very quick bit of background before we get into the details. So why do we need to secure an embedded system? What actually is it that we're trying to secure? And the reason why a lot of existing embedded developers haven't got experience of security is that historically their embedded systems were not connected to a network, so they were considered secure if you just put them in a secure box, for example. But obviously, as soon as you've got an external network involved, then those IoT devices become part of some larger ecosystem, and you don't want them to become a vulnerability as far as cybersecurity threats are concerned. And in terms of what sort of things are we trying to protect within our embedded systems, then assets or properties, so things that an attacker might want to get their hands on, can be physical, so things like controlling hardware or the environment. Maybe they're after data, so particularly personal information that will have some kind of value. Maybe they're interested in the internal operations of the product you're working on, algorithms. Maybe if they just want to cause problems and maybe give your company a bad reputation for reliability and so on. So those are the sorts of things that we need to protect. And if you've never worked on a secure system before, you might naively think that it's fairly straightforward. You just need to buy the right components. So, for example, if you start off with picking some secure hardware device, so some secure microcontroller, for example, we write our software in a way that's going to be secure. So maybe using secure libraries, perhaps there's a switch on the compiler that will make it secure, and connecting to some kind of secure network. Well, unfortunately, that doesn't really work. And to be honest, there is no standard off-the-shelf solution that will actually do the magic for you. So if you want to create a secure embedded system, so something like an IoT device sitting at the edge, you have to do a lot of the work yourself. You can't just buy something and plug a few bits into it. And that's challenging. If you've never done that before, then where do you start? Okay, so let's have a look at some of the things, areas where you might get started. And it's also worth stressing that every application will have different requirements. So a particular combination of components that works for one application may be completely unsuitable for something else. So that complicates things. And say different applications will also have different requirements in terms of things like cost and so on. So a solution for one application may be too expensive for another application. Okay, so that makes it challenging. So where do we get started? And obviously, as we just heard, there's legislation which is on the horizon or is actually here now. So here are sort of just three quick examples picking up from the last presentation. So we've got the PSTI Act that is now in force in the UK. Coming up in a couple of years' time, there'll be the European Cyber Resilience Act. So that will have big implications on terms of how do you actually structure your design to make it secure. And over in America, there's the upcoming US Cyber Trust Mark, which is not a regulation as such. It's something that's intended to be optional, but the idea is that consumers will buy products that have the Cyber Trust Mark on, and if your product hasn't got that mark, then you're not going to be sort of a competitive. Okay, so there's legislation, but does that give us any clues as to how we get started with a secure embedded system? Well, let's take a look at some of them in a bit more detail. We start off with PSTI because that's now a current requirement in the UK. If you have a look at what is actually inside the Act, you might be surprised that it doesn't actually say an awful lot about security. In fact, there are only three main points or three main requirements. First one is related to passwords. And as we heard with the Mirai attack, the reason that was able to proceed was because a lot of devices had default passwords which were never changed. So it makes a requirement that passwords have to be unique per product or defined by the end user. It doesn't actually say that you must have a password, which is quite interesting. And again, if you're designing a system, it doesn't really give you much help in terms of how you get started. Okay, what else is there? Well, there's information on how to report security issues. So when you're creating your embedded product that's going to be secure, you have to provide a mechanism that's going to allow you to let users know of any vulnerabilities that get discovered. But again, that doesn't give you much help when it comes to getting started. And the last one's equally sort of vague in terms of information on minimum security update periods. Okay, so yes, once you've finished, it's good to know how long you're going to support it for, but that doesn't help you to get started. Okay, well, let's have a look at the European legislation then. Perhaps that might be a bit more sort of informative. And certainly the Cyber Resilience Act is a lot more comprehensive. There are a lot more points that you need to address, a lot more requirements. So it does say a lot more about what security means. But again, it's written like any kind of legislation to be generic and universal. So if we look at some of the clauses, for example, so we've got a requirement that we've got a product and it shall be delivered with a secure by default configuration. In other words, if there are security parameters that can be enabled, then they should be enabled by default rather than something that the end users has to set. So that gives you a little bit of extra sort of insight as to what you might need to do. So you need to have some mechanism for providing secure by default products. We need to ensure protection from unauthorized access. Okay, so could be a password, it could be some kind of certificate or some other identification mechanism. So it's giving us a little bit more insight into what is required, but it's still not a design specification. Okay, so we still need more than that. Now, we've already heard about the EN 303645 standard. In fact, both the Cyber Resilience Act and the PSTI are sort of closely linked to that. And if you get hold of this document, again, you can freely download these from the internet, then that does indeed give you a bit more information about what might be required. So if we take the example of passwords. So there's a section on requirements for passwords, so no universal default passwords. And it gives you even an example of how you might implement that. So that's starting to look a bit more helpful. If we get examples, examples can help us to make sense of what are the requirements and therefore lay down our own requirements for the products that we're working on. If we want further information, though, again, the standards don't really give us enough. So where else can we look? Well, fortunately, there's a number of guidelines which have been published which can help us. And in particular, if we're going to be using the EN 303645 standard, there is an accompanying document, which is this TR 103621. And that has this rather grand sort of title, Guide to Cybersecurity for Consumer Internet of Things. And if you look at that, what you'll find is basically it goes through each of the requirements for the 303645 standard and gives a number of examples of how each one could be solved. And that's exactly the sort of thing you need when you're trying to make decisions about how do you implement the requirements for security, what are those requirements, and so on. Now, you're watching an IoTSF webinar today. If you weren't already aware, the IoTSF has actually created a whole set of best practice guides to cover exactly the sorts of questions that you might want to be asking. And in terms of getting started with our embedded system, probably the most useful one is this secure design one that I've highlighted here. And that takes you through a number of different aspects of what it means to have a secure by design product, and gives you hints about the things that you need to consider for each of those different categories. Now, again, it's not a specification document. It doesn't say you must use this component or you must use this particular cryptography standard or anything like that. Okay, but it's nevertheless still very useful. There are some other guides which you might also find useful within the development process. So one of the requirements for forthcoming legislation is to have a software bill of materials. So if you haven't created one of those before or even met one, then again, the guide is helpful to give you an insight as to what's required there. And another requirement for the Cyber Resiliency Act is that you have a vulnerability disclosure scheme. So again, there's a guide that tells you how you might approach that. Okay, so again, not necessarily related to the upfront getting started, but still things that need to be taken into account. Okay, so are we there yet? Have we actually solved the problem about how to get started? Well, not quite. And what we're missing is we're missing a plan. Okay, so we can't really start working on our secure embedded application until we know some kind of plan for work. Now, software engineers for many years have been using a software development lifecycle to take them through the various steps that are required in order to complete their tasks. And that's fine for regular software, but it doesn't say anything about security. So what we need to do is we need to find some way of adding security into that software development lifecycle, or SDLC as it's commonly referred to. And there are different approaches for creating an SDLC. There's the traditional waterfall approach, where you go through each step in a sequential manner, starting off from the initial design and then sort of finally going through to test and product release and so on. If you're using a agile approach with sort of a CI/CD flow, there's also SDLCs that fit into that approach. Or maybe you're doing something else. You've got your own in-house approach for creating your design lifecycle. Well, how do we go about adding security features into these steps that we know that we've got to do anyway for any project? Well, again, another free resource that's very useful to get your hands on is this NIST special publication 800-218. Okay, so in case you're not aware, so NIST is the sort of a US National Institute of Standards and Technology. And they have written a lot of the documentation that defines standards and guidelines related to security. Okay, so part of the sort of US government. And the this NIST 800-218 Secure Software Development Framework, or SSDF, sets out how you can go about adding the required security features into your SDLC. Okay, so if you download it and start reading it, then in the sort of introductory pages, it will tell you that it contains a core set of high-level secure software development practices that can be integrated into the SDLC implementation. Okay, so that's exactly what we want to get started. Okay, so let's assume we're using a traditional waterfall approach. Well, our SDLC could look something like this. So we've got our standard steps with sort of requirements, gathering, design, implementation, verification, release. And for each step, we've added appropriate security activities. So during the requirements phase, we're not just talking about functional requirements, we're also gathering the security requirements. In the design phase, then we're doing threat modeling to look at what are the threats that we need to make our system secure against, and then designing in countermeasures that will allow us to produce a secure system. During the implementation phase, then there are coding guidelines that we can follow in order to keep track of how we're writing our code, to make sure that we don't repeat well-known errors that have led to previous security vulnerabilities. So things like having code that allows a stack to get overflowed, and therefore that becomes a security vulnerability. So rules have been written, so you've got maybe familiar with the MISRA-C rules and C++ rules. So the latest versions in 2023 include security as a feature. There's also the CERT-C and C++ coding guidelines as well. Now, if you want to check that your code really is secure, trying to do that by hand isn't very satisfactory. So it's expected that you'll be doing that in conjunction with static analysis tools that will analyze your code and make sure that you haven't broken any of those secure coding guidelines. In the verification step, then we can be running dynamic analysis. So running code to see, can we break our system? So can we cause something bad to happen? So not just functional tests, but also running security tests. And a common approach here is to use what's known as fuzz testing. And with fuzz testing, the idea is to effectively generate pseudo-random inputs that are going to allow the computer to basically try millions of different inputs to see if it can find something that breaks it. And some of the fuzz testing tools will also take a genetic approach, so that they will actually learn for evolutionary approach. So they will actually use previous results in order to guide them for the next set of random vectors. In the release phase, we can do a final security review. So have we met all of our security requirements? And then finally, for the response, we can have a response plan to indicate how we're going to respond to things like reports of vulnerabilities and updates and so on. Okay, so we could add all of those steps into our existing waterfall approach if that's what we're using. However, you don't actually need to do that yourself, because Microsoft did it 20 years ago. So the Microsoft SDL was created for internal software written at Microsoft, and there's even a textbook that you can get that tells you exactly how they've done it. It's no longer in print, but you can still get secondhand copies, or you can actually download it if you do a search from the Microsoft website. Okay, so that's one approach. Alternatively, if you're using an agile approach, then the Cloud Security Alliance have created a DevSecOps delivery pipeline, and that essentially then maps these same sort of security activities onto an SDLC, which is oriented towards a continuous integration, continuous development flow. Okay, so it's the same sort of ideas. So we've got a plan. Is that everything that we need to get started? Well, you might still be feeling a bit unsure about what's meant by security. So another useful document to look at is this guide, Secure by Design. Okay, so Secure by Design is a publication from the US cybersecurity infrastructure cybersecurity and infrastructure security agency. In other words, they go under the moniker of CISA. And this document has been written in conjunction with a number of other security agencies around the world. So in the UK, and Europe, and also then in Asia and Canada as well. So a number of well-respected security agencies have also given their input into this guide. And it basically gives you a set of principles for manufacturers to help create their secure by design products. But before we actually get started, we might also want to consider business requirements, because security is something that you have to actually do within a business operation. So there are costs and things associated with it. So you need a security policy. So for example, if you break any of the legislation, somebody in the company needs to be responsible. Okay, so there's management involved. There's processes that need to be set up for handling vulnerabilities, updates, managing the SBOM, and so on. And if you want to get detailed information about that, again, the IoTSF can help, because those things are also covered in the security assurance framework. Let's have a quick look at that. And in the security assurance framework, what we have is we've got a number of requirements, in fact, over 200 on all aspects of the actual development that we need to do for security. If we take a look at one of them, then we've got a policy here for addressing risks that basically say that it's mandatory, you have to do threat modeling in order to work out what the risks are going to be. Okay, so there's a whole set of these, and they're outlined in the document. If you're an IoTSF member, there is also a questionnaire which is available to members that you can use as a checklist to make sure that you've actually met all the relevant requirements. Okay, so finally, how do we actually implement this? Well, if we've got our SDLC, how does that relate to the IoTSF guidelines? So here I've got an example which I'll quickly go through some of the points. So I've created a mind map which maps onto the various aspects of the assurance framework. And what I'm going to do is I'm just going to quickly go you through a demonstration. If you want to see this for yourself, there are full details on the Dulos website. We've got a link that's you've already been given. And the idea behind this is that for each of these different branches, we can break it down and we can look at what's required at each step. So for example, if we're up at the top, we can look at the initial requirements. So what needs protecting, what are we protecting for, the risk assessment. So what are our security goals and safety requirements, what levels. So when we're looking at what we're protecting from, then we can look at different approaches for threat modeling, types of attacker, protection profiles, and so on. Notice that training was mentioned, so I should have highlighted that as a training company. But one of the things that Microsoft found was that very few software developers actually had sufficient knowledge of security. So they made it a requirement in their SDLC that every developer had to have training on security at least once a year, because they found that even though there's lots of security courses, they tend to focus on things like what cryptography is all about in the internal operation. It doesn't tell you how to create a secure system. Okay, so for each of these different elements here, then we can go through and break them down into different elements which correspond, for example, to different standards, different ways of doing things, And also here, the sort of boxes here highlight particular points in the IoTSF documents. Okay, so those are what each of those different points are. So unfortunately, we haven't got time to go through all those different stages today. But say if you go to the link that's been provided, there is a document that takes you through all the steps as to go through this mind map with the different phases. And then there's also a link to the actual mind map itself if you want to explore that in more detail. Okay, so I'm sort of aware of the fact that I've used up all of my time now. So let's return back to my last closing slide. Okay, so how would I summarize what we've talked about today? So firstly, there's a lot to learn about embedded system security before you can even get started. So don't underestimate the time and the effort involved. Okay, so that's I think a common mistake. People think it's just going to be easy. I think especially some management people think that there isn't really much effort involved. It's just a question of buying a couple of components. And as I said, unfortunately, that's not the case. Ideally, what we want is security by design. Okay, but that only works if you plan it from the start. You can't have security as an add-on. And if you adopt a security development secure software development lifecycle, that considers security issues at each step. And the IoTSF security assurance framework and questionnaire is a good place to look to give you a checklist to make sure you understand all the requirements and compliance. Okay, so on this slide, here's the link that was mentioned earlier. So on the Dulos website, there's a link there to a whole bunch of information related to what we've been talking about. So information about our embedded security courses, as well as some recordings from previous webinars that we've done, and some tutorials related to security as well. There's also an option there if you want to just join our email list. Okay, and just to finish off, here's my advertising slide, just highlighting the sorts of courses that Dulos does. Okay, so hopefully that's given you some ideas, and I'll hand it back to Christopher.
Dave, thank you very much. Dr. David Long of Dulos. As mentioned previously, if you'd like to hear from Dulos, those links that David was talking about, one of which is a special landing page which has been created especially for David's presentation today. Go to dulos.com/IoTSF webinar, or if you're watching this live, the link is in the Zoom chat facility right now. So just before we get into the Q&A section, by the way, if you've got a question for either Dave or Chartai, ask away in the Zoom chat facility and do it quick before we get started. I'm going to tell you a little bit about the 10th IoT Security Foundation Conference, which takes place on Wednesday, the 23rd of October, 2024, at London's IET, just down from Covent Garden. This year's theme is IoT security, past, present, and future. We've had loads of submissions from people who would like to present at the event, so we'll be looking at the abstracts and getting back to everybody in due course about those. In terms of sponsorship, we're now very limited, but you can still go to IoTSFconference.com and look at the sponsorship brochure. We've still got spaces left for exhibitors too, if you're interested in that, and why would you not be? The event is the world's longest running IoT security conference in the world. This is where the thought leaders, the influencers, the innovators and the experts will be. They'll all be in one place on one day. Go to IoTSFconference.com for all details and register now. And you can also watch a short video of last year's event to see what it's all about. So to today's Q&A section, and as is customary, I'll start off with a couple of questions of my own. Chartai, I'm going to bring you in and ask you, how can you manage the talent that you've mentioned required to achieve the sustainability that you were talking about?
Okay, thank you, Christopher. Actually, as David has just showed in his mind map, every actually point in that map we require something to do. For example, you have to make a penetration test to your IoT ecosystem to first find your vulnerability. And in order to, for example, make that, you can get that service from a third party, but that party should know about the embedded penetration test, mobile and cloud altogether. If you, for example, ask for a IT-based security company, it may not be enough to find your real vulnerabilities in your IoT ecosystem. Secondly, after getting that vulnerability report, you should apply the related design solutions into your system, and that design solutions may be in your mobile app or cloud, etc. So you have to create such kind of expertise in your company. If you want to take all of them outside from third-party companies, then you should align all of them all together. That may not be so easy. If you want to create all the know-how in your own company, again, it may not be so easy to, let's say, find such kind of expertises. And even if you find, it will again not so easy to keep those experts in your company, because there will be a huge demand in this sector. So what will be critical is that the regulations actually requires an IoT know-how, IoT expertise. Some IT companies actually approaching top-down approach. I mean, they know very well the IT infrastructure, classical security infrastructure, and they are trying to penetrate the bottom with the mobile app and embedded. But that may not be so effective. What we experienced in Beko and then CyberWiz was that bottom-up approach. I mean, coming from the embedded side and then making it connected, making it secure, and then creating an end-to-end ecosystem, continuing with the mobile app and the cloud side, will actually make the life easier for us to be compliant with the regulation, Christopher.
Okay, thank you very much for that, Chartai. Dave, how can I translate my existing embedded system into a secure IoT edge device?
Okay, well, that can be quite a big question, because obviously it depends on how close to a secure system your current hardware and software really is. So the first thing you really need to do is do a proper threat modeling. So you need to work out what is the actual application that you're working with, where are the threats going to come from, what are the interfaces, and I try to identify what are the most critical aspects that you need to address. Because the chances are, if you've got an existing embedded system, unless you can throw it away and create something completely new, you're going to have to put up with the fact that some things are less than ideal. So it's a question of really sort of costing the various threats that and solutions that might apply, and then looking at where you can fix things and making sure you need to do just enough in order to give you the level of security that's required either for your customers or to meet the requirements of a particular regulation. So I'm not sure whether that sort of answers everything, but
Dave, I'm not here to ask you easy questions. I cannot tell who this question is for, so I guess I'll just ask it to both of you. Chartai, I'll ask this to you first. This is from Narissa. Is there coordination with manufacturing of devices so security is just not software-based, but also physical? Something external that can be plugged in or embedded only for occasions of stopping an attack. Can this be considered, since attacks always come through software or the internet or passwords, walls, etc.?
Most of the attacks will be like that. But I mean, we should think about every possible scenario, including making some physical attempts into the device. If, for example, we are using the same key, even if, for example, PSTI is asking to use unique keys for the products. As you all know, there are many companies still actually preferring doing nothing about PSTI. So if we, for example, embed a software key and use it in all of our device, in case of such an physical attempt, it will mean that we will be losing whole devices in the field. So that is why we should first think about, start to think about the product itself, and then we will continue to the last point in the cloud API.
Okay, Dave, I think that question was for ChartEye, but have you got an opinion on that one?
Well, yes, in terms of hardware devices, yes, there are hardware devices that can be selected either as the basis for your product or as add-ons. So a secure element is a fairly common add-on to a lot of existing systems. So if you want to handle things like keys and even sort of cryptography operations in a more secure fashion than is possible with your existing, particularly a small microcontroller, then it may be possible to add that in and to allow that to take control of all of the security features. That will also have added advantages. Not only maybe you can use more powerful algorithms because they're now done in hardware rather than software, but additionally there may be vulnerabilities which are hardware related. So in the early days of smart cards, then people thought they were secure until researchers showed that you could use side channel access to effectively decrypt the keys or extract the keys from smart cards. So smart card technology has advanced a lot since then to make it much harder for those kind of physical attacks. But if you've got, for example, like an AES algorithm running on a standard sort of Cortex-M microcontroller, then it's relatively easy to find side channel attacks if you have access to the physical hardware in order to break into them.
Okay, thank you. This is a question from James, and this one is for you, ChartEye. You mention monitoring of IoT devices as a requirement of CRA. Is that meant to be real time? And if so, how many organizations in your experience actually monitor IoT devices and systems for cybersecurity attacks in real time? IP video cameras, access control, BMS, and others as an example of this impacts building security risk or routers as they are managing these devices.
Actually, as I mentioned, the companies are struggling even to be ready for the just 3 mandatory items of ETSI for PSTI. I mean, there is still some way to go for the industry to establish that monitoring infrastructure. It is also a recommended provision in the ETSI standard, not mandatory. But what we see from our home appliance industry is that as far as we see, there is no awareness about it. There is no urgency about the companies to create such an infrastructure. In the regulation, it is not very well defined to make it real time or not. It is just writing a monitoring. Most probably in the coming years, it will be more definite, and some maybe notified body laboratories may be able to make some comments about it. But as Beko, we created such an infrastructure. We are collecting security related data from our IoT products in the field, and also we are collecting security related data from our mobile application, which is used to control and monitor those devices continuously. We are monitoring them actually continuously. But to be honest, it will be one of the most difficult provision that manufacturers will have to obey, because it will require to embed some software agents into the device. It will require some related design in the cloud side, etc. It will be the hardest one, I think. But as you know, the automotive industry has already started to do. In July, there is a new regulation in the automotive industry, UNECE R155 and 156. During the life cycle of their automobile, actually smart automobile, they have to monitor their infrastructure. They call it VSOC, Vehicle Security Operations Center. So as we see, there is no very common usage and awareness about it for now.
Okay, thank you very much, Chartai. A question for yourself, Dave. This is from Paul. Can you please say a few words about how supply chain security, for example, application of SBOMs, fits into the SDLC?
Okay, so I didn't have time to show that during the presentation, but again, if you take a look at offline at the mind map, you'd see that that is covered as part of the secure design and architecture phase. And then within that phase, one of those I've broken down into defenses and countermeasures, and then the SBOM is then coming under that at a company level.
Okay, thank you very much. Another question from Narissa. By the way, ask these questions in the order that they come in on the chat facility. We've still got a couple of minutes left if there's any more questions. Narissa asks, I think this one's for you, Dave. Is AI being used already in dynamic analysis and fuzz testing in SDLC waterfall? Are there guidelines in using AI, both from threat identification and recommended solutions? Also for Dave, it seems like from the mind map that it is best that instead of having the ideal universal system, that each user, especially for massive confidential info database, i.e. government agencies, banks, etc., be designed uniquely dedicated to their purposes and organizations, i.e. DNA type can't be replaced due to uniqueness. What is your opinion on this? That's a bit of a war and peace. I hope you got all of that.
Okay, we'll start on the first one. In terms of AI, then I'm not aware of any commercial threat fuzz-based tools which are currently using AI, but I'm sure it won't be long before they emerge. One of the sort of features of fuzz testing is that a lot of the tools out there are actually developed by security researchers, and quite often they'll have a bit of a following and then they'll disappear and something else will take over. So within that community, I'm sure that there are people using AIs to help fine-tune them to see if they can sort of go down paths which are more likely to break the system. And then in terms of the mind map, I would say that having something that is completely unique for every different project is not practical. You still need to have some basic framework that people can work with. And on the mind map, even though there are lots of different branches, it may well be that for a particular product, some of those branches are not appropriate. So, for example, some of the branches relating to things like secure mobile applications wouldn't be applicable if you're creating an edge device that had no kind of mobile interface. So I would say take those sort of steps as being your starting point, and then customize it to meet the requirements of your project. And each project will then have probably different steps, but you should still end up with something which achieves the intended results.
Right, as happens every month, we've had an absolute avalanche of questions when we're running out of time. Chartai, this one's for you. If you could answer very, very quickly, 30 seconds or less. This is from Daniel. How are consumers informed of the data collected by monitoring? One of my business partners' 6-month-old washing machine was bricked last week, and in troubleshooting, he was astounded at the volume of data it had reported back to its HQ, not just whilst the machine was washing clothes.
Yes, there was a very famous tweet in the previous month. One of the washing machine in the world was sending more than 1 gigabyte data to the cloud. we also surprised because in the current standard home appliances, the bandwidth of the data is really very low. It is less than 1K, and it is not sending it actually when it is not running. So and the end user is being informed during before the usage of the mobile application. I mean, we are just explaining what kind of data that we are collecting. It's very standard, low volume data, actually. It shouldn't be so high.
Okay, one question that I can answer because it's been put to me from Emmanuel. Do we have any chapters in the US? Yes, we do. Houston, Texas, and I've put my email address in the Zoom chat facility, Emmanuel. So if you want to know more about chapters, just get in touch. One more question. This is from Richard. And I'm not sure who this is to. Business and consumer devices are often looked at differently. How is the industry deciding what is enough security for consumer devices versus B2B devices? I think that sounds like it's probably for you, Çağatay. Can you answer that one quickly?
IoT is very broad in the horizontal scale. For us, for example, we are only focusing the consumer vertical. The industrial IoT side or any other critical infrastructure side is very different, and there is no regulation for those for now. The regulations are just being discussed for the consumer vertical. And when you look at, for example, the scope definition of the regulations, it is defined actually. Toys, home appliances, smart TVs, etc. The industrial side or the B2B infrastructure is very different. It has its own characteristics and realities and challenges, actually. It will not be enough to discuss it in a minute.
Dave, I don't know if you've got an opinion on that last question, but I'll give the final word to you.
I think so. From our experience, particularly for people that are looking at, say, industrial IoT type applications, is they often sort of have, say, completely different requirements in terms of what they've considered security, and often they've considered their sort of threats are things like industrial espionage, things that will damage their business interests. So they'll have a different set of requirements to, say, a consumer who maybe has very little knowledge about what potential risks might be. But there isn't a standard to help them there. So they generally have to sort of try to sort of look at what the various suppliers can offer and try and make sense of it themselves. So it would be helpful if there was a standard.
Okay, that is all we've got time for. It is the half hour in India or the hour in most other time zones. So apologies for not finishing on time. Just quickly, on next month's webinar, we'll have Sam Cater from BT, and he'll present on IPv6 and IoT security, considerations for engineers and solution designers. We'll also have Vaidi and Ram from the IoTSF's Chennai chapter in India joining us. They'll be showing us around their smart city lab environment, and they'll be speaking about how this is useful for learning, research, and product development. You can register for next month's webinar now. The link is in the Zoom chat facility if you're watching this broadcast live. As mentioned previously, go to the IoTSF conference, go to IoTSFconference.com. for any and all details about this year's 10th edition. The sponsorship and exhibitor brochure can be found there, as well as our confirmed speakers so far, which include Dr. Leonie Maria Tanzer of UCL. We've also got Apostle Vasilev of NIST and Matt Tett of the IoT Security Trustmark. He'll be flying in all the way from Melbourne, and if that name sounds familiar, he is a previous webinar speaker. My thanks today to today's special guests. They were Dr. David Long of Doulos and Çağatay Biop-Topçu of Beko and CyberWiz. My name's Chris, and we'll see you again for next month's webinar. Thanks for joining us today.